All right, everybody's
Okay.
got to repeat everything they just said. Okay, no problem. Okay,
Sorry to interrupt you, Jenny.
That's
Peter,
okay, I've finished.
Peter, in your flying around Africa, did you ever go to any of those countries?
Yeah, we used to fly over Lake Kivu. I never thought about it. I must admit, I had never heard of this until this video came up. I didn't know about this, and I just find that the whole thing is so alarming. I mean, they mentioned 300 cubic kilometers out of Kivu of this toxic gas. 300 cubic kilometers. That's a huge amount. And I just also wondered about the fish in these lakes. They must suffer they must die as well.
Well, I mean, that CO2 is only, remember, it's only at the bottom. So the fish would be
But fish swim
mostly
around the bottom as well.
Yeah, but most of the fish would be near the surface where there's oxygen.
Yeah.
I think if you send a robot down, it's not like the bottom of the sea. You know, where you do have some life. I think you have very little life at the bottom of the lake.
Yeah, well, any fish that do go down into the gassed area would die anyway. So there probably wouldn't be life down there anyhow, because it would, if anything had ventured in, would probably expire.
Yeah, all that kapenta fishing that they have, like in Kariba, is based on that turning of the water when it actually turns all the, that's when they do the fishing, which is a very largely consumed edible thing for the local people there. But my worry I would have is, with the Wagner Group wandering around the way they do, if somebody wanted to actually create, at the moment, if Rwanda actually owns all that territory and you've got the Congo wanting to get it back, it's actually a weapon that you could save having to spend a lot of bombs. Just send one of those things down there and you could probably create havoc the way things work in Africa.
I think that as far as Lake Kariba is concerned, they're fortunate in that it doesn't happen to lie on a volcanic line. As far as I know, Caldera might. It might. I don't know.
Now, I think they're pretty much the same sort of latitude. They're just in the tropics, but
the same latitude, but the longitude. The Caldera is quite a bit to the east of of Kariba, and I don't know. It seems to me that could lie in that line.
But I think
both are man-made lakes, Peter.
Probably
sorry, interrupting.
Sorry,
sorry, both of those are man-made lakes when we know exactly the rivers, what they looked like before that land was flooded.
True.
So it's not entirely the different situation, much more shallow.
Yeah, and Lake Kivu is very deep, very vast. There's probably there must be some inflow and some outflow, but relative to the total volume of the lake, it's very low, even though it could be a lot. The lake is just so big. So the turnover of water and the flow, there's no real currents flowing through to disturb that carbon dioxide and so on.
And a 4,000-year cycle would never happen in a man-made lake.
Yeah.
The northern part of Zimbabwe and into Mozambique is not a volcanic area. It may be in the future as the rift more extends towards the southeast of Africa, but I don't think we'll be around to worry about that.
I agree.
By the way, I don't know if any of you have seen the thing where they found with the what is it, sort of a sonar or whatever, the detection, seismic detection. Scientists have detected these massive globules above the molten mantle. One is, I think, under the Pacific, and one is under Africa. massive, sort of an enormous mass of this molten magma. They reckon it's the remnants of possibly the remnants of the planet, which they call Theia or something, which hit the Earth and created the moon.
Yeah, there's several theories because the molten core of the Earth isn't all sort of concentrated in a nice bubble in the middle. There are these two large lobes.
Yeah.
There's also a thing called the African superswell, which is a name given to the fact that Africa is rising, particularly the south and southeast. And they don't know why it keeps rising. I mean, the highlands, the high felts of of northern South Africa is part of that superswell, and they don't know what's causing this, ongoing, very slow, but ongoing elevation in the southern part of Africa. So there's obviously something happening down below, but it's difficult finding information.
Makes one wonder whether Elon Musk isn't right with his mission to populate Mars.
You mean destroy Mars?
Yeah, well.
Yeah.
We've done a very good job of Earth. I don't think we should be allowed to go up and destroy another planet.
Yeah.
Yeah, there's already a lot of junk lying around Mars from things that have crashed.
Yeah, no, we don't understand it here, in my opinion.
I know it's a total topic change, but thinking about Mars, there was a recent report about the scientists who tried to occupy that environment. Where was it created? In Wales, was it, for 2 years? And for 2 years, they really struggled to maintain a way of life in a closed atmosphere. And it became extremely interesting. They thought they could generate oxygen by growing plants, and the plants would absorb the carbon dioxide that they produce. Did anyone else read that report recently? Most interesting. I think it says that life on Mars will be impossible.
That is interesting.
Yes, I think I saw that, Mick. It was also quite a surprise that.
Can you send us a copy on that, David?
Yeah, I'll try and find it again. Yes, thank you.
Thanks.
But getting back to the other topic, the thermal vents, the deep sea underground thermal vents has been very useful to science because they've used the bacteria from those vents to leach copper in sulfide ore deposits. So that bacterial action, I think it's bacterial. Anyway, so there's some very interesting thermal vents around the world.
Microbial, but they get their energy from. They don't have an oxygen energy cycle. It's based on the sort of anaerobic situation down there, and as you say, chemicals and stuff.
And interesting creatures. That one half of the creature lives in the hot water, and the other is in the cold water at depth. There's some very interesting biology and zoology that happens down there.
Totally different to normal organisms up on where we are. Totally different biology. Metabolism.
Does anybody know the critical CO2 concentration level?
Critical for?
Well, critical for life.
Yeah,
I mean, how much CO2 concentration do you need for it to stop supporting life?
Well, you just need if you have a bubble of CO2, it pushes oxygen away, so you just get zero oxygen.
Yes.
So
I do understand that. I'm just wondering what there must be a critical level.
It'll be on Wiki somewhere.
There was something on that. I don't know whether it came through. I think it was with James Webb, that it was getting to those moons. Is it the Europa, one of the moons which has got that? It always just looked like a round moon, but when they got closer to it, they found that, in fact, there is a very big ice below that level of cloud. And that if they could get into that ice, if there's water and rock interchanging, then life could exist on that moon. So it's and they were saying that a lot of the experimentation for eventually going and trying to find out what's happening under the water there, would be experimented with on Earth, because it's a whole lot cheaper than sending the wrong thing up there and 25 years later, whatever it takes to get there, finding it was the wrong machine. So the lady who tells us about the things they have to invent for space and going around the moon, it sounds like Mr. Musk will be looking for other things to, when you get to the moons of Jupiter as well, because there's chance it's the nearest thing to us they think that water and life could exist. Did you see that anywhere? I would have to go back and look for the source. I don't think it came from astronomy.
It was an interesting topic.
Yeah, this level of CO2 is actually quite intriguing now that I think of it, Peter. So maybe someone should just Google it. It's probably a simple answer on Google somewhere. But I should imagine that, I mean, if you're in the open air, you have to be in a depression or in an enclosed room or something, even if you're in a room with windows open, you know. And I mean, how many cases have there been, even with, you know, with gas, where people had gas geysers and they've been in a bathroom and closed all and had a bath, gone to sleep and never woken up again because the geyser had burnt up all the oxygen in the room and left them with only carbon dioxide to breathe, and they die.
Carbon monoxide, I think, Derek.
Okay, that could be monoxide, which is much worse, yeah. Because
it's your exhaust pipe.
Yeah.
Has anyone looked up the carbon dioxide levels that we can survive with or not?
What do you find?
The computers in your pockets, remember?
Sorry, say again, Jenny?
So is anyone looking it up? We're all sitting with computers in our pockets.
45 millimeters of mercury.
That are lethal to human life.
I think about the answer there.
So we're talking about it. Phone with me.
I'm typing, but I type slowly.
It's 45 millimeters of mercury. It's a quick answer.
45 millimeters. Okay. But what's that in atmospheres or bars?
Yeah, or percentage.
I put it on the table. I'm not explaining it.
Okay.
May I speak while you look up?
Okay, go ahead.
I saw an interesting picture of trees around a volcano where the volcano starts getting active and the trees are greener around the volcano than far away from it. So the trees get more CO2 when the volcano starts rumbling. But in the case of these lakes tonight, there's so much CO2, it just kills off everything, all the nature as well.
Yeah.
Everything in moderation.
Okay, I've got an answer here. AI overview. Carbon dioxide can become toxic to humans at high concentrations with levels of 40,000 ppm, which is 4%, I presume, in the atmosphere, or greater, considered immediately dangerous to life and health. Exposure to such high can cause loss of consciousness, death due to oxygen deprivation.
No. So what is our normal concentration of CO2 in the atmosphere as a sort of average, normal?
Low levels under 1,000 ppm considered safe and are typical of normal outdoor air. Moderately, so 1,000, which is 1/40th of that dangerous level, is normal. So moderate levels of 1,000 to 5,000 ppm may cause symptoms like headaches, drowsiness, and tiredness, especially with prolonged exposure. High levels, 5 to 30,000, can cause severe dizziness, increased heart rate, sweating, and difficulty breathing.
Yeah. So we've got a bit of leeway. It's not sort of incredibly sensitive.
Yeah, the problem is you don't know it's there. That's the big problem. You don't realize it's there until you pass out.
Yeah, but I mean, I know about them now, but it like this.
It's probably what happens with beer as well. When you have a hangover, it's all the CO2 that's emitted that gives you the headache, maybe.
The medical people can tell us the right story there, I think.
I'm a brewer.
But this interesting industrial safety concept here, because entering any enclosed space like a tank, it has to be proved to be, you've got to ventilate it first, because it's more than likely to hold carbon dioxide, particularly sewage, of course, and like sewers. You can't just walk in there without adequate breathing protection.
Wine cellars can be pretty dangerous to people that are not careful. There have been a lot of accidents where people have gone into a wine tank to clean it out, and then somebody goes looking for them and they find them, they're dead. Because, of course, CO2 is a byproduct of fermentation of sugar.
Yeah.
So they have to, again, they have to ventilate the tanks, by opening up valves at the bottom before climbing in to clean it out.
Yeah.
Some people don't get the instructions, and then as a result, they die.
So there are quite a lot of dangerous situations.
David, I'm just wondering, and maybe Jenny would know, but wonder if it's the actual carbon dioxide that kills or the lack of oxygen. Because, I often find when we have very, very high humidity, I mean, there is so much moisture in the air, never mind carbon dioxide, that one can actually feel it. Most of every breath you take, the most of it ends up being water, moisture. And so I'm just wondering, is it the carbon dioxide that kills, or is it the lack of oxygen in every breath that kills?
It's the lack of oxygen. So that's why carbon monoxide is much worse, because the carbon monoxide actually absorbs oxygen into itself to become carbon dioxide. So it rapidly depletes the oxygen in the atmosphere.
Is that what it says on Google?
What?
Because I disagree with your explanation.
No, okay, give us the correct one. I'm speculating.
Now, my understanding is that carbon monoxide, not dioxide, I don't know enough about CO2, but certainly carbon monoxide is it kills, because in the bloodstream, it's taken up by hemoglobin cells. That's 60 times more easily than normal oxygen is. So if you have a high concentration of CO2, just carbon monoxide, it preferentially it's taken up by all the hemoglobin, which normally carries oxygen. So the oxygen can't bind. So it's sheer volume overtakes, or it's the hemoglobin likes carbon monoxide, or vice versa. They like each other very strongly. So if you have high enough levels, you don't get enough oxygen binding, and therefore you don't get oxygen circulating.
Okay, but it's a different mechanism to what I said, but
in the end,
it prevents the body from getting oxygen, which is what kills.
In that sense, but it's not because it's sort of the levels are relevant, obviously, but it's the fact that that carbon monoxide attaches preferentially to hemoglobin, and this is why people who die of carbon monoxide poisoning are always very pink in color, because they've just flooded all the hemoglobin, but it's also killed you. So you've got this very, very red coloring, but you're not around anymore.
Therefore, it's a poison rather than a
It basically it stops oxygen binding, but it's about the way that hemoglobin and the chemicals interact chemically.
Hold on, just close the door.
What happens with CO2, I don't know, because it's not something I know about.
CO2 just displaces the oxygen in. Just leaves you leaves you without oxygen to breathe in. I think that's all it is.
Yeah, I don't know whether CO2 just actually attaches preferentially like carbon monoxide does, or whether the mechanism is different. If you inhale it.
It's a density difference. CO2 is heavier than oxygen, so it sinks to the bottom and displaces the oxygen from the atmosphere.
Yeah.
So you're
I
just
don't
breathing
understand. I'm quite sure.
CO2 in only and not O2.
Yeah, but as I say, how it actually affects, respiration, I don't know. Not something else, but we can all look it up.
Yeah.
Going back to the wine and the beer one, I can tell you that in the brewing process, they actually collect the oxygen at fermentation stage and then use it again in the bottling process to pass over, particularly with cans. If you pass CO2 over the can, it's heavier than air, so it dispels that. When you seal that can, there's no oxygen in there to oxidize the taste of the beer. It's one of the agings. So
No,
it
no,
reuses the
absolutely.
CO2.
Yeah, wine bottles. If you are a garagista, you pump a little bit of carbon dioxide into every bottle before you fill it.
Yeah.
May I mention something?
Yeah, go.
I found this topic very interesting, the dangerous lakes. And I thought one of the items might have been these beautiful colored lakes that are very acidic, that one has seen maybe in Russia and in East Africa as well. That's just for interest. The point I want to make, I want to bring up the Bermuda Triangle. One of the theories that was put forward many years ago that I recall today was that one of the reasons why aeroplanes may have disappeared is because of these huge pockets of methane gas and whatever else that collect under the sea level. I know it's not on the Atlantic fault with Africa and Americas, but the Bermuda Triangle, they reckon that these big clouds, underwater clouds, when released of methane gas, could interfere with instrumentation and swallow these airplanes. That was one theory that was put forward, and it doesn't sound sensationalist, having seen this tonight.
Mm-hmm.
So it's just a pilot crew that they've sort of passed out, and that's it.
There is in northern Russia and also in parts of northern Canada, with the melting of the tundra, which locks in huge amounts of methane gas. This methane is being released as the ground softens. And I don't know quite what they call them, but there are sites of many eruptions. They look a little like impact craters, but in fact it's an outward explosion. And the thinking is that this is methane which has now been liberated as the tundra softens and temperature rises, and that the gases accumulate under the ground and eventually reach some crucial point at which they basically physically explodes out. And there are areas of northern Russia that are covered in these sort of these craters. So
Jenny,
the methane is being liberated, and it's quite dangerous.
Yeah, Jenny, that's probably caused by climate change and the loss of permafrost.
That's part of it. Yeah, the permafrost is melting. But apparently huge amounts of methane are held in permafrost.
Yeah, and which is far more lethal.
But they are
worse for the atmosphere.
They found these, look like small impact craters, but in fact, if you look at the pattern of the actual thing, the force is from the bottom up. It's not coming from upside downwards into the earth. It's actually some energy coming up from below the ground. And this is probably what they are saying.
Yeah, they leave depressions behind. Yes, absolutely.
Yeah, they look a bit like meteorite impact craters, but the trouble is it's happening in areas that are unpopulated. These are the wilds of northern Siberia and things. And so by the time they find them, often by accident, there's no evidence left. There are no sort of high methane gas levels and things because it's all already happened. And then you find that areas collapse. The areas where conifers, areas of fields of conifers just sort of sink into the ground because the earth under them is being, the gas inside it and the permafrost is melting. And so the soil becomes unstable, and there are whole, forests of conifers that sort of just sink into the ground. There's a lot of stuff on there, lots of images on the internet you can see on this.
The other thing with methane, of course, in a very deep ocean, it forms a solid. It forms almost a sort of this white lumpy material like an ice, a methane ice, and they have actually brought up samples of this. They bring it up with these robot diving things, and it scoops up a sample, and it's still solid by the time it gets to the surface, and they put a match to it and starts burning.
Yeah.
So that is also a thought. They were thinking of trying to mine that at some stage. I think it's just too expensive though, for the amount you can get.
But there is also, as part of climate change and global warming, there is an increased release of methane in the oceans, and there are places where you can actually you can see videos on YouTube and things of this stuff bubbling up, and of course it's potentially explosive. I don't know anything about where it happens or anything, but I have heard about that.
And of course, as a greenhouse gas, it's multiple times more powerful than CO2. And the worry is that you could reach a sort of turning point where this stuff just starts releasing all over the place, and
well, this is the problem, it's
raising the concentration in the atmosphere so much that it causes a sort of runaway effect.
Yeah, much faster than just carbon dioxide would.
Yeah.
Really a happy note.
So who's for supper and a beer now? Some CO2 and alcohol. All right, that was very interesting. I think, it's good to find these things out and be sort of aware, in case somebody offers you a cheap holiday house on the shores of Lake Kivu. Anyway.
At least you don't have to worry too much about the flatulence of the cattle. There's a lot of other methanes around.
Don't mention that, please. Don't mention that. The farmers will go crazy.
No, the cows are still, unfortunately, a contribution to warming.
Right. I think, there's a lot of methane produced in sewage and so on. I often wondered if they can't change their, some people, the very green people, build these bio tanks or whatever underground and put all their leftover food and chop bits of vegetables and stuff, and even compost, and dump it in this thing, and it creates methane, and actually use that to generate electricity and stuff. I wonder how much methane is wasted in all the sewage in a city.
I do think that's actually been seriously tried, and I can't remember who tried it, but I do think it's been tried, but just not cost effective, I think. I don't know.
Quite a few around. Around the Ananda Dam in KwaZulu-Natal, there's quite a few toilets that have been built on that basis, and it's the problems of their usage, and that is more cultural, and you can imagine the but certainly the people who introduced it, I think, could have been Danish. I'm not sure. Somebody were experimenting with them around there, and they were on a number of the properties. One found them.
Sites all have to have methane release, and in fact, quite often they burn it off, because that's all part of the sort of biodegrading of organic material.
Yeah.
And so that they always have to have some way of letting methane escape from landfill, and so quite often they burn them off, like fuel refineries do. Same thing. So they're just pumping more into the air, but at least it's safe in that sense. It doesn't sort of cause problems at a sort of human level.
Right. I will, as usual, be sending the transcript to Peter. Peter, do you want the attendees list, or do you know who they are now?
No, I've got the attendees. Thanks very much.
Okay.
We had a total of 10 tonight.
All right. Okay. Any ideas for next time? That's some interesting.
For next time?
Yeah, next study group.
Next month. No, I haven't got anything in line yet.
I had a couple of sort of semi-suggestions this evening.
Yes, by all means. Go ahead.
Yeah, I forgot. Did you mention something that was, I don't know, dangerous lakes? You thought these other lakes would be mentioned? And then the other thing is what Jenny's been talking about, the methane effect of sudden methane release all over the show around the Earth due to global warming and so on.
That's a big topic.
Yeah.
Okay, I've made a note of it, so well, check up on that.
Might be something comprehensive in our length of video on YouTube somewhere about it, which goes through all the various aspects of that. All right, and then there's a lot of stuff happening on energy generation and all kinds of things on YouTube. So there may be.
Yes, sure. And Ab, you sent me some stuff which I must admit, I have to confess I haven't really looked at seriously. It's on my little work pad here, but I haven't looked closely at it yet. But thanks for the suggestions, Ab.
And if anybody, any of the attendees have got interesting suggestions, let us know.
Please do.
Right. Go ahead, Ab.
So I met the coordinator of the U3A Paleontology Geology group.
Yeah.
And I attended the get-together on Friday, where he gives feedback on all the rocks that he's studied now in the Fish River Canyon and in the Richterveld. But there was an 1.5 hour long video and discussion and intro on evolution from various aspects.
Okay.
A touchy topic if one starts touching on religion, but he took it solely from a current science data-based point of view. So gosh, there were about 40, 50 people attending. Huge interest. But essentially his interest is in the rocks and what the rocks tell him because of the beauty. And yeah, that's why he runs this tour group. He runs tours for people who are interested, and then they go and do various things. So I know some people in the complex, they went with him on a 10-day tour, going all the way to Meyeringspoort, up the west coast to various places. So that's his interest. And he said he will respond to my email request when he gets a chance to put some topics on the table that might be general enough.
And if anybody's interested in American geology, that American guy that I mentioned once, Myron Cook, I watched his one of his new videos again a few days ago. He's based in America, and it's different to sometimes often to other parts of the world, but it's still very interesting, and he puts things so well, you know.
Derek, there's a fascinating series that's actually on Prime Video. It was made by a guy from the Smithsonian. He's the resident or the geologist at the Smithsonian, but it's on Prime Video, and it's lovely. It's just how North America was made, and the graphics are fascinating. I mean, they can do so much these days with graphics.
Okay,
I don't know if there's any. It's called How North America Was Made. There are 3. It comes in 3 parts, and it's on in the documentary 6 section of Prime Video.
I'll go and look for that. Yeah.
Okay.
All right.
Okay. Did you say the documentary section of Prime Video?
Yeah,
yes,
that is. That's Amazon, isn't it? Or
yes, Amazon Prime. That's correct.
No.
Yeah.
Oh, I subscribe to
Amazon. Okay, I've made a note of that too.
No.
Plenty to keep me busy here.
All right.
Thank you very much.
Thanks. Very interesting. See you next time.
Thanks.
Bye-bye.
Cheers.
Thanks a lot, everybody.
Thanks,
Terry.
everybody. And good evening.